Hello everyone and welcome to my talk, Automatic Testing for Accessibility. I would like to quickly introduce myself. I'm Anna. I'm an IT consultant at CodeCentric in Germany, and I've been a software developer for quite some time. In the last year, I've mainly worked in the front end, and since 2019, I'm also busy with the topic of accessibility. Back then, I joined the accessibility task force of the company, and I got hooked on this topic, and that's why I'm standing here now. This is the agenda for today. Before we're going to dive into testing, we're going to look at what accessibility actually is. And then I want to show you the testing tools that we have for accessibility. After that, I would like to give you some inspiration for writing your own tests for accessibility. And in the end, we will have a look at what AI can do for accessibility testing. Defining accessibility. So I would like to get us all on the same page of what I mean when I talk about accessibility. A lot of people think that it has to do with blind people, because obviously they cannot see the screen, so they need some special software and we need to accommodate for them. But accessibility is actually meant in a much broader sense. This is the definition from the European Commission. I'm going to read it to you. Web accessibility allows everyone, including people with disabilities, to perceive, understand, navigate, and interact with the internet. So in other words, accessibility is for everyone. And it makes complete sense if you think about it, because we're all different. We have different backgrounds, different genders, ages, skills, education levels, and there's no such thing as this average normal user that we're all building our software for. So accessibility means that you are building your software for the widest variety of users possible. And with this definition of accessibility, now you might ask yourself, okay, how do I accommodate for all these varieties? Luckily, we have some guidelines for that. The most important ones are the Web Content Accessibility Guidelines. They were created by the W3C, and they are really set as a standard. So around the world, they are used as a basis for laws. Next year, there's going to be a new law coming into effect in the European Union that will also enforce accessibility for some parts of the private sector. So it might be that you will encounter accessibility in the future. The guidelines are also really extensive, so they have a so-called success criteria, and we have 86 of them. And I cannot really go much into this content, but I want to show you the structure of these guidelines. For that, we will look at this page here. This is the quick reference. It has all the information about all the guidelines. And I picked one guideline at random to show you what the structure is. So this is all the information you have about this success criterion 1 to 2 captions. Lots of text. I'm going to walk you through this. So this line here in gray, this is the actual success criterion, and it is formulated in a rather vague way. And the reason for that is that these guidelines are developed very slowly. The release cycles are several years. And in the meantime, technology advances really fast, so the guidelines have to be robust against these changes. But of course, if you have a really kind of vague criterion, it doesn't really help you to figure out how you can comply to it. So in addition, each criterion has an understanding document. This is linked here on the right. And this understanding document gives us background information about the criterion, gives examples, and also has techniques and failures. I always stumble over this word, techniques, sorry. And so these techniques and failures are also listed here. They tell you, the techniques tell you how to do it. So any one of these three techniques is sufficient to fulfill this criterion, but this list is not exhaustive. You might come up with some other techniques that might also fulfill this criterion, because this is just an informative information here. So, and also, the same goes for failures. So there are 3 ways how you can fail this criterion, but also, again, this is not exhaustive. You might fail it in some other way. Yeah, why am I showing you this? Because I want to show you that there is not like if A, then you fail it. If B, you don't fail it. With accessibility, it's always really complex, and one does not simply automate this. But this is a talk about automating stuff for accessibility, so let's look into that. Let's look at tools for test automation for accessibility. Here are some common automated testing tools which I use. And the first one, X, is probably the one you're going to encounter most. It is open source and it is built in a lot of other frameworks. How do these tools work? Well, they're doing a static analysis of your page. So you render your page, you give it to the tool analyzes it and gives you back some results. And then it might look like this. This is a screenshot from Google Lighthouse. So you have actually an automated accessibility testing tool right in your Chrome developer tools, and which is nice. And it lists all these problems here that it found on this page. And then there is just one slight problem with this presentation, because it looks like if you fix all these problems, that then you reach 100 here, and then your page is accessible. But this might not be the case. And the reason for that is that these tools cannot discover all the accessibility problems. How much can they discover? Well, that's a matter of debate. I'll show you two extreme positions. For example, the vendor of X, they say that their tool can cover or find on average 57% of WCAG issues. And you might think, okay, this is not really a high number, but if you live in the accessibility bubble, this is a high number for an accessibility testing tool. Yeah, and along come the accessibility experts. They do their own tests. They come to a quite different number, between 0 and 13.5%. And yeah, how come we have these different numbers? Of course, they use different metrics. So the vendor of X counted the total number of issues found, and the experts counted the amount of criteria that were covered. In this debate, there's no clear winner in the end. There's only like a consensus which is reached in the community that these tools can cover between 20 to 30% of the WCAG failures. And yeah, it is quite low, I'm afraid. But nevertheless, sorry. Why is it so low? Yeah, we have some criteria which are not automatable, so it's actually not possible to reach 100%. One example for this would be this criterion here, which says headings and labels describe topic or purpose. Right. So if you have a page like this, this is the Devox FAQ page, and yeah, the tool cannot decide if these headings describe the topic or purpose, the thing that they're heading off. Only the creator of the page can decide this at this point. Another problem is that even if the tool covers a WCAG criterion, it's often not covered completely. One example for this would be the very first criterion of WCAG, and you don't need to read this wall of text. I summarize it for you. It basically says, provide descriptions for your images, unless it doesn't make sense. And if you are faced with an image, like this one on the Devox homepage, the tool can tell you if you forgot to pull an alt attribute, but the tool cannot tell you what you should put into this alt attribute. Is the image decorative? Then the alt attribute should be left empty. Or does the image actually provide information, which is vital? Then the information should be in the alt attribute. And again, this is only for the creator of this page to decide, not for the tool. Yeah, nevertheless, automated tools are useful because they find these boring things like, okay, I forgot to put this attribute, thank you, tool. And this way they provide a baseline accessibility. And also, of course, their analysis of accessibility is more consistent than of a human tester. If you want to use such a tool, it only makes sense to run it continuously, so put it in your pipeline somehow. And you also have to do something with the results. So it doesn't free you from concerning yourselves with accessibility. Especially not since you also need to do additional manual testing. Okay, let's look at some code now. For this presentation, I created a very fancy, example app with React and Next.js, but it's not really important. I will show you some tests I wrote. I used a vtest and the testing library, and for end-to-end testing, I used Playwright. This example app is in a GitHub repo, and I will give you the link at the end of the presentation so you can look at the examples in your own time later if you want. Right, okay, let's see how we can use an automated testing tool on different levels. Let's start with the unit test level. And as I said, I'm going to use X. For vtest, there are two options, vtest_x or just_x. I choose just_x because vtest_x seems to be abandoned. And this is how you use it. You have your fancy component, you render it, you just throw it over the wall to X. X does it magic, gives you some results, and then you assert that you don't have violations. When would you do this? When would you put it in your unit test? I think this is exactly the use case. You have a fancy component like, I don't know, a menu or a dialog, and you want to ensure some baseline accessibility for this component. Then we can also use a tool on the end-to-end test level. With Playwright, there is this library at xcore/playwright, and the usage is very similar to the usage on the unit test level. So you render whatever you want to render. In this case, I go to the page. Then I give it to X. There's some more boilerplate here, but it doesn't matter. This results object is the same as you get on the unit test level, and you can make your assertions on the violations array. When would you use it for on the end-to-end test level? I think this is most useful if you have a dynamic page or some kind of flow, maybe, I don't know, checkout or something. And then in each stage of your flow, you can run X on the page as it is in this state, and you can ensure this baseline accessibility for all the states of your flow. What you can also do is put your automated tests into the pipeline directly, and for that there are several frameworks. You can, for example, use Pally. This is also open source. It gives you a command line interface, and if you want to use it, all you have to create is this file here, this .pally.ci file, and in this file you see I put these two URLs it should run on. Afterwards you can just put a script in your package.json or call it directly, whatever you want. And here I just ran it locally, and it is just doing the same thing as all the tools do. Using the same algorithms. So Pally is actually using HTML code sniffer, but you can also run it with X. And this output here, of course, it doesn't make sense to just have it in a console. You can create reports from the results. And Pally also comes with a dashboard where you have an overview over the accessibility state of your various sites. And this is the fastest way to get started with using an automated testing tool. But I'm not, I think this is most useful if your pages are kind of static, if you don't change much, because then you just render the page, run the tool, and then you're done. But if if the page changes, then you need to you rather put it in your end-to-end test. This is for the automated tools, and I don't know about you, but I was not very happy with these 20 to 30% coverage, so I wanted to come up with more ways to test for accessibility. The one big advantage that we have over the automated testing tools is we have context, because we are building this app and we know how it should work, we know how the user should interact with it, and the generic tool does not know that. And with this knowledge, we can write tests for accessibility. I'm going to show you 3 examples now. And in this GitHub repo, which I already mentioned, there's a couple of more which just didn't fit into this presentation. So let's go to the first example, keyboard navigation. There are several aspects of keyboard navigation that are important for accessibility, and one of them is the focus order. So if you tap over the page, the order should be logical and you shouldn't just jump around wildly. Here you see my example page, and on the right I use the tool to highlight the focus order. What I want to show you now is a very simple test for keyboard navigation. I just want to test that the very first thing in my focus order is this back to main link. And I will test that on the end-to-end test level, but you can also test it on the unit test level. So this is the start of the test. So first thing I have to do, of course, is go to the page. And if I do that, my initial focus is on the body element. So the next thing I have to do is press tab. And there's this keyboard property of the page where I can access the keyboard and press all the keys there. And then for my assertion, I want to get the element which is now keyboard focused, and I can do that with a CSS selector. The *:focus visible gives me the keyboard focused element, and then I can have my assertion on it. And yeah, it's really simple, right? So you can easily see how you can expand this test and do more complicated things. I don't know, open a menu, move through a form. Yeah, what I would like you to think about is that maybe the next time you write an end-to-end test and you find yourself writing click here, click there, that you might remember how simple it is to write a test for keyboard navigation and write the same test again, also using the keyboard. Because if you do that, you already come a long way for accessibility. Keyboard navigation is really crucial for accessibility. Let's move on to semantics. If you look at this page, just by looking at it, you understand what these elements mean. Because there is some underline here, you know that this is a link, and because of the box here, you know that this is a button, and this meaning is called semantic roles. So all of these things have a certain semantic role. And important for accessibility is that these roles can not only be deduced from looking at a page, but they are also encoded into the HTML. Because if you do that, then assistive technology can make use of it. For example, if you use speech recognition, you can say to your speech recognition software that it should click the link, and the speech recognition software will find out, okay, there is a link, and I can click on that. So how do you actually figure out what the semantic roles of the elements of your page are? You can go to the accessibility tree. You see it here. This is a screenshot of Chrome, and where you would normally have your DOM tree in your tools, I have now the accessibility tree. You can activate this tree by toggling here. So clicking this guy will toggle between the DOM tree and the accessibility tree. If the little guy is not there, you first have to go to the accessibility pane and click this checkbox here. And what do we have in the accessibility tree? Well, the nodes of the tree are the semantic roles, actually. So we see there is a heading node, and it refers to the heading. The link node, it refers to the link, and so on. So this way we can review the semantic roles of our elements in the page. Yeah, by the way, if you're using Firefox, there is a separate pane for the accessibility tree. So you don't need to look for it in the elements pane. So how can we test this now? I again want to write a really simple test for that this thing here is a heading of level 1. I will start on the unit test level. And this is the test. I use testing library for that, because testing library works with the principle that things should be selected by their role or by their semantics. So it provides selectors for finding elements by their role, for example, the find by role selector, and it is rather trivial to use. So I give it a role, and in my case, because I want to find the heading of level 1, I also give this parameter here. If you have a different role like a button, you can here, for example, set if it's active or not. So the parameters here differ depending on the role. Yeah, and that's it. You select the element and then you can make your assertion on it. And if you're on the end-to-end test level, you can do the same. There it's called get by role, but it works really the same way. And the thing is, if you start selecting your elements by semantics instead of selecting them by test ID or CSS selector, then you are implicitly asserting that the semantics of the page are correct. And this is, again, good for accessibility. The last example is about layout. There are again several criteria for layout. And I picked the text resize layout. As you can see on my example page, on the right it's at text size 100%, and on the left, of course, and on the right it's on a text size 200%. And as you can see, things are not looking great here. And this is exactly what this criterion is about. If you increase your text size to 200%, everything should still work, and this should definitely not happen. And at this point, you might wonder, increase the text size. I only know the zoom. Yeah, so if you want to increase the text size in your browser, you have to go into the browser settings. You can also use a plugin to increase the text size, or you do it developer style, open the console, and or rather, you open the developer tools, select the root element, and just give it this styling here, font size 200%. And at this point, the text on your page should increase. If it does not increase at this point, you have a problem, because then the criterion is already failed. So you need to fix that first. Well, this is how you can manually review it, but you can also test this. And for that, we want to look at, I want to look at the size properties of HTML elements. So this element here has several properties about its height. One of them is the client height, which tells us how much vertical space we have available. And the other one is scroll height, which tells us how much vertical space we actually need. And yeah, as you might figure out now, if the scroll height is bigger than the client height, then it's running vertically outside of its box. And we have the same criterion also for the width, so we can test both dimensions. So I will show you a test now on the end-to-end test level. And the thing is, I cannot test it on the unit test level, at least not with VTest, because VTest is using JS-DOM, a headless browser, which didn't implement these layout features. So if you're testing for layout, you have to look out if the browser that you're testing on actually supports the layout features. So this is the playwright test. It will get a bit longer. The first thing we have to do is increase the font size. With this evaluate function, you get access to the underlying DOM tree. And document element gives you the root element. And here you set just the font size to 200%, like we did in the developer tools a few slides back. After that, I get the element which I want to test. And yeah, then I can call the evaluate function again. And this time I call it on the element, which gives me then the selected element already as an argument of this function here. So I can directly compare the properties and figure out if it fits inside the container and then make an assertion on it. When is this useful? I don't think this is useful on every page, but if your page has like a very strict layout where it's very important that things stay in their boxes, then you might consider writing such a test. And as I said, there are other layout criteria, not only increasing the font size, but also that things should work under certain dimensions, and also that you have a certain text spacing supported. And you can all set these properties here with the evaluate function before you run the test. Yeah, so these were a couple of examples for automated tests, and at this point you might wonder what do I need to test for accessibility? What is what is left to test? Yeah, for accessibility testing, I always give this recommendation. This is a plugin for Chrome and for Edge. It's called Accessibility Insights, and it runs automated checks, but after the automated checks you have a long list of manual tests, and it guides you through manually testing your page for accessibility. So this way you learn about what you need to do for testing, and you also might get some ideas of what you could probably automate. Yeah, so let's move on to AI, and I just want to make sure that we're on the same page again, because I'm talking about, of course, the technology we currently call AI and not some other AI. And yeah, the big question is, can AI fix accessibility? Why do we need to concern ourselves with all this testing stuff? Cannot AI take the page and make it accessible? And if you ask marketing, AI can do that. Marketing says yes. So there are a couple of tools out there who say, okay, we will make your page accessible. And the way these tools work is they take the page and they enhance it with their algorithm, and afterwards it should be accessible. And the question is, does this work? Yeah, so I went to a couple of the testimonials of these tools to figure this out, and within seconds I ran into the first accessibility problem. Then I figured out, how can I show this to you, because I didn't want to make screenshots of the customers of these tools. But then instead I made screenshots of running automated tests on these testimonial pages, and these are some of the results. So these tools do not even fix the issues that the automated test tools can find. Yeah. So why is that? Why is it so problematic to fix accessibility with AI? Several reasons for that. First of all, AI is built on inaccessible data. So there is this company, WebAIM, and every year they make a report on the top 1 million web pages of this world. And all they do is run their automated testing tool on it and report how many failures they find. And this chart shows us how many of these pages had at least one failure. And as you see, yeah, I think it was 95.9% this year. Yeah, so this is the data which is AI models are trained on. So AI has a huge bias for creating inaccessible HTML. And then there is this matter of context. A lot of people use AI for image descriptions, and you might think, okay, this is a solved problem for accessibility because you can just put an AI model on all my images on my homepage, I'm done. Because it works perfectly, it describes everything here, right? Yeah, the thing is, you don't use this image in isolation, you have some context, and depending on the context, the description might be different. If I would use this image on my personal website, I would of course highlight my dog because he's adorable, right? But if I would use this image on a real estate website, then the dog would just be a prop, and I would focus instead on that there is a lot of room and I can go to the outside. So generic AI tools cannot, they do not have this context, they can only provide you generic solutions, and they might not be appropriate for accessibility. And the image description is only one example. There are lots of criteria that heavily depend on context, yeah, which AI fails if you don't provide it the context. Yeah, and give you some seconds to savor this awesome page. yeah, the biggest reason why accessibility cannot just be solved by AI is because it's not a technical problem. So if I would make this page here 100% accessible technically, it would still be an accessibility nightmare because it was not built with accessibility in mind. It was a complete disregard for its users, basically. And accessibility is all about users and about their needs and about how they interact with the page. So a technical problem, trying to solve a problem, which is a conceptual thing, with a technical solution just doesn't really work. Yeah, but still, AI is useful for accessibility in a lot of ways, and I just will show you two which are related for accessibility testing. When I created this talk, I of course tried out if AI could create my test scripts, and it works kind of. So lots of instructions I have to give it, and I put in some more work to get it up to my coding standards, but it kind of works. But now there are already tools out there who use AI to generate entire GUI test suites. And I would probably give them a bit more time to mature, but I think at some point in time we will be at a point where we'll just tell AI what kind of tests we want, and it will create them for us, and that will be a relief. And another road where AI will help us with accessibility testing is the automated testing tools will probably become better with AI. One example for that is if AI can recognize these semantic roles for us using image recognitions. So the AI figures out, for example, this is a button, and then it can compare it with the actual code and alert the user if there is a mismatch. And the vendors are already working on that. DQ has a blog entry, very interesting one, where they explain how this works, and I think they're already in the beta phase with this. So this 20 to 30% coverage will probably increase in the future with AI. Yeah, that's all I have to say. If you're interested, please check out the GitHub repo. You can also contact me on LinkedIn. And if you have any question, just come to me. Thank you.
All systems are nominal. Initialize Genesis sequence.